So here, basically what we find was that if you're developing complex robotics behaviors or working on complex robotics tasks, normally you're not working alone. You're working as a team, or most autonomous behaviors, you're now wanting to kind of also collaborate, for example, with machine learning experts or data scientists or AI tools or even test engineers. So what you want is to be working on all the development and robotic tasks, but doing it within a team. And what we found was that the tools weren't really compatible with doing that easily. And also, as you do more and more simulation for building complex behaviors, you need more compute power, and your laptop runs out at some point.
Yeah, very much.
So these were the two big things that we identified early on. Okay, it needs to be a lot more collaboration and less developing only in silos. And you need to basically to connect whatever compute you want. And that's kind of where we started. So we've developed the biggest sandbox you could create, where you can have a digital source of truth for your whole project. Everyone can work on that and populate it with the same assets that you're all developing. And then you can choose to work in your integrated development environment, either on your local machines or in the cloud, or we can connect to on-prem servers or supercompute as needed.
Wow. Okay. So that seems like quite a lot that you guys are doing, like many different permutations of things that you may be doing for customers. You've kind of iterated to all that, whereas some people want on-prem devices, so how does that, tell me a bit more about that whole journey of getting to all these different solutions, and then also how you have a common part with all that, because it sounds a little bit like you could be spreading yourself thin, supporting all these different things. But tell me about that.
It took us quite a long time to build our MVP. Let me put it that way. This wasn't a quick app that you just create.
Yep.
So we're talking about serious infrastructure that we're building. So we use Kubernetes so we can connect that to any compute.
Wow.
We use a lot of containerization, but often in a project you're looking at something that's very complex. So you're talking about the total toolkit can quite often be between 10 and 20 gigabytes. So, and then you're collecting robotic data that's large files that aren't easy to upload into Google Drive or whatever. So what we find is that actually the tools that you need for robotics are professional level tools, and they don't really exist. So rather than reinvent the wheel or develop lots of complex behaviors, we've focused on developing the toolkit needed to do the job. And how can we professionalize robotics development? And if you can enable teams to work together, then projects can be run faster. And projects or products or robots that are developed by multidisciplinary teams will be stronger as a result, rather than developed by one PhD person working only on their machine in a little silo, trying to connect that all to more of a digital source of truth that many can collaborate on will give it a higher chance of success, and also a higher chance of surviving way beyond the development stage.
Definitely. Yeah, because especially if you can get people working on a system together, it's like you don't have as much difficulty in setup, you don't have as much difficulty setting up testing. Like everyone doesn't have their own Docker file or a different approach to get the whole system set up so they can develop, and you just manage it for them and for the team.
Take all of that away. But what you find is that lots of robotics engineers say, well, I've got it set up exactly as I want it. I've got this driver and that driver and this driver, and this is exactly as I want it. So you can still work like that. You can still have all of that.
Okay.
But we enable you then to have 10 other people also working on exactly the same setup that you've got.
Yeah. So what was the abstraction you made for that? Or how do you enable that kind of workflow? Because that seems like very different things. So I have a Docker container, I'm forwarding my X11 or whatever it is, things so I can have visualization. How do you support diverse workflows where you have it on the device and you have it in the cloud and on the browser, or however it works?
Yeah, so we kind of see the projects of, so the number one, what are the tools am I using? Then what am I actually developing? So what's our assets?
Yeah.
Are we actually creating? And then what do I want to do with it? Okay. So first of all, the toolkit, it's all just files, yeah? It's all just, so off the shelf, we've got different gazebo versions and ROS distributions. You got things like SLAM and navigation and standard. So all the things that 80% of all ROS projects probably use the same basic 80%.
Yeah.
And then anything which is more specific, you can either add it to your base image if you want everyone to have it, or those are just simple, easy modules that can be added. So we then turn them into components, which are like assets. So in the same way your test environment can be an asset, or your URDF can be an asset.
Yep.
Little drivers and components can also be individual assets. So then you can say, okay, whenever I'm setting up the project, this is my toolkit, and then I'm populating it with all of these assets, which is capabilities and things to work on.
Yeah.
Okay? And that's all set up in an easy mix and match way, because we see the future of kind of the software side of robotics being more mix and match. So it's different behaviors that you want people to do.
More modular.
Much
you
more
grab
modular.
the components you want.
Yeah.
Ah.
And so if you encourage people to set it up that way, it's also easy for people to understand why this is in the project or not. And you're bringing it in because you want it to do a certain functionality, or you want your robot to have a certain behavior.
Yeah, it's purposeful that you've added
very purposeful. And then it's also easier for then when you're setting up the next project to the next project to the next project, people understand why things are there. It's not just hidden in one big file.
Yeah, for sure.
There's one person with a PhD's brain.
Yeah.
And all of a sudden it becomes something that's more accessible and people understand what the different things can do and then why different projects are set up in different ways. So it's also about skill dissemination, transparency.
It's more accessible.
And it's
in
about,
general.
yeah, and then everyone can learn together. And then as you're publishing your project, so for example, we have an open source project, one of the ones which might be showing in the background, and it was 3 different ways of doing navigation, all built on top of ROS.
Ah.
So it was to the field navigation, up and down the rows, navigation, and precision docking navigation.
Cool.
That started off as one big file, and we split it all up. So that the test environment was separate from the rover robot, which was separate, which was then all these different navigation packages. And it's all published in a way that people can go in, demo it and trial it, and then say, well, I don't need all the other stuff, but I do need precision docking. So I'm going to take that part and I'm going to put it into my next project. And we've also got 2 other research projects saying, actually, that test environment's super useful because it's got a field and it's got this. So we're just going to take that test environment and use it as an input to our next project.
Yeah, so much more composable robotics projects.
Yeah.
That's very cool.